Now the question is, they are giving you some parameters. One is virtual address space or logical address space is given so and so, which means the size of the process. And next thing is page size is given as so and so. And next one is sometimes they are not, the PTE means page table entry, right? So now they are either missing this one or this one. Earlier we have seen that they have given the page sizes and the page table entry size and they missed up the virtual address space, right? But in this question they are giving you the virtual address space and then they are missing you either page size or page table size. Then you are supposed to fill those. The question is this: fill the blanks in such a way that page table will fit in one page in single level paging, which means they are saying that there is only one level paging, which means there is only one page table. See, in single level paging there will be only one page table, right? So they are asking that in single level paging, if the page table has to fit in one page, then what is that you are going to, how are the parameters going to be? Right? Okay, let's see that. Now if the page table has to fit in one page, you know this, page table is nothing but number of entries in the page table multiplied with the page table entry. Now these two multiplied, which means number of entries into page table, the page table entry size should be equal to the page size, right? So they are asking if that condition has to be satisfied. You guess everything. Okay, let's see this. Now first one is virtual address space is 4 MB. Virtual address space is 4 MB, and then page size, PS means page size, is 4 KB. If this is the case, then I want to find out how many pages will be present in the process. If process size is this and page size is this, I want to find out how many pages will be present in the process. Why should I find out? Because depending on the number of pages, the number of entries in the page table can be derived. Therefore, number of pages equal to virtual address space divided by page size, which is 4 MB divided by 4 KB, which is 1K pages. If these many pages are there, right, then let us say page table entry size, I don't know, let me say it as E. Now the page table size is equal to the number of pages, that is equal to number of entries into the size of each entry, let me say E. So number of pages into size of each entry should be equal to the page table size. Now what is the page table size here? We don't know that yet, but then they are saying that each page table should fit in one page. Therefore, what can you say? Number of pages into entry size should be less than or equal to page size. Why? If this has to fit in one page, no, this should happen, right? Therefore, number of the size of the entry size is less than or equal to page size divided by number of pages. So how much is that? Page size is 4 KB divided by number of pages. So number of pages is 1 KB, 1K pages, right? Therefore the entry has to be less than or equal to 4 bytes, right? Therefore what is the maximum page table entry size? You can go till 4 KB, 4 bytes. If you go till 4 bytes, then it will fit in one page. Understood this? Okay, so it is less than or equal to, why I have taken it is, I am assuming that the page table has to fit in one page, right? Therefore it can be less than or equal to. In case if you put equal to, it means that you are finding out in such a way that the exact page table size and page size is equal. So look at the question and you can go with that. Sometimes they'll say that it should fit in it, and sometimes they say that it should be exactly equal. In that case, either you get less than or equal to or this. So let's put PTE should be less than or equal to 4 bytes, because they are saying that it should fit in one page. They didn't say that the page size should be equal to that. Therefore, if the page table entry size is less than or equal to 4 bytes, then you can fit the entry this entire page table in one page. If the page table entry size is greater than 4, then it might not fit. That is the question. Okay. Now look at the next one. The next one also they are talking about the same kind of thing. So one is page virtual address space and page size, both are different here. Virtual address space is 4 GB and page size is 128 KB. And what is the virtual address space? 4 GB. So 4G means 32. 2 power 32 divided by 128K means 2 power 17. Then how much is this? It is I'm thinking about something else. 16, 15, 2 power 15, right? So 2 power 15 is the number of pages. Then page table size equal to number of pages into entry size. Number of pages into entry size is less than or equal to page size. But here the page size is different. What is the page size here? The page size is 128 KB, which means 2 power 17 divided by page table entry size is pages are 2 power 15. Then how much we get? 2 power 2, which is nothing but, right? Therefore it is 2 power 2 is 4, right? Again the same thing. So entries should be, the entry size should be less than or equal to 4 bytes. Entry size should be less than or equal to 4 bytes. Same thing, right? Okay, next one. Next one is also same kind of question. 128 terabyte is the virtual address space. Virtual address space is 128 terabyte and the page size is 32 MB, right? And in order to find out the number of pages, I should find out virtual address size by page size. Then what is it? Virtual address space is 128 terabyte means the tera means 40 and 128 means 7. Therefore it is 2 power 47 divided by page size is 32 MB. 32 means 5 and M means 20. Therefore it is 2 power 25. Then what do we get? We get here 2 power 22, right? And now page table size is equal to number of pages, which is equal to the number of entries in the page table into E, right? So number of pages, okay, are you understanding this? Why did I write pages into E? Because according to the number of pages in the process, the number of entries in the page table will depend, and therefore page table size is number of entries in the page table into the entry size. So pages into E has to be less than or equal to this. So entry size has to be less than or equal to page size. So what is page size here? Page size is 32 MB, which means 2 power 25 divided by number of pages. So number of pages is 2 power 22, which is 2 power 3. Therefore entry size has to be less than or equal to 8 bytes. Alright? Okay. And now next one is, it is interesting. Next one is, we are supposed to design the page size given already page table entry, right? Then we are supposed to decide the page size in such a way that one page table will fit in one page, right? So now watch it. So what should be done is, we don't know the page size here, right? So page size here not given. Okay. Okay, let's do it from the beginning. So page size is not given, then we are supposed to decide the page size in such a way that if each entry size is 4 bytes, one page table should be able to fit in one frame, right? Or one page table should be able to fit in one page. That is given here. Then how can we solve it? It is better that you assume page size is P and then you can go ahead. You can go with that. Either you can assume that page size is P and you go ahead with this, or if you want it to be done easily, you can assume that page size is a power of 2 and you can say 2 power k is the page size. Anyway you can do it. I'll follow one way. You can follow any method you want. What I'm going to say is, you can directly say that take the page size to be P bytes, or you can take the page size to be 2 power k bytes, so that calculation will be easy. Okay. Now watch it. Virtual address space given here is 256 MB. So what is 256 MB? 2 power 28 bytes, right? And now page size, let us assume that page size is P bytes. This is what I assume, right? Then what is that we should do? Find out the number of pages first. So the number of pages equal to virtual address space divided by page size. What is virtual address space? 2 power 28 divided by P. This is the number of pages, right? And now what will be the page table size? page table size will be equal to number of pages into page table entry size, right? So what is number of pages here? 2 power 28 divided by p into what is the page table entry given? Here already page table entry is given as 4 bytes. This is the page table size, right? And now if this page table has to fit in a page, then definitely page size should be greater than or equal to this, right? Therefore what is the condition? Page size, one page size has to be greater than or equal to page table size. Then what is page size? P has to be greater than or equal to 2 power 28 into 4 divided by p. That implies p square is greater than or equal to 2 power 32. That implies p is greater than or equal to 2 power 16, right? So what is 2 power 16? 64k. I think you know this math. I'm not going to say this, okay? And p is greater than or equal to 2 power 16, which means the page size should be at least 64 KB. So page should be greater than or equal to 64 KB, which means if your page size is as big as 64 KB, it will be able to we'll be able to put one page table in one page. If it is greater than that, fine. If it is less than that, it is a problem. Okay. Now we can solve the next two also in the same grounds. Now next one is 512 KB. So instead of 256 MB, next one is given as 512 KB, right? So what is 512 KB? 2 power 19 bytes, right? So it is 2 power 19 bytes. And now page table size is number of pages into page table entry. So it is 2 power 19 into what is the page table entry size? 2 bytes. It is 2, right? So it is 2 power. Now it is 2 power 19 into 2. So how much is it? It is 2 power 20, right? Then p is greater than or equal to 2 power 10. On the same routes I solved it. Therefore what is the page size? Page size has to be greater than or equal to 2 power 10 bytes, which means 1 KB, right? And what about the next one? 16 GB is given here, right? So here 16 GB is the virtual address space. That equal to what is 16 GB? G is 30 and 16 is 4. Therefore 2 power 34. 2 power 34 bytes, and the page size is p bytes, right? It is 2 power 34 divided by p. 2 power 34 into page table entry size is 4, right? So it is 2 power 34 into 4 is 2 power 2, therefore it is 2 power 36. P square is 2 power 18, right? Then therefore in this question, how much should be the page size? 256 KB. Page size should be greater than or equal to 256 KB, right? That is how you can solve all the equations. Okay, this is one model. Fine. Hey, in the previous question, what happened is this one is actually 32. This answer is 32. The reason is 256 MB is 2 power 28. I think you have figured it out, right? And into 4 is not I have added, I think instead when I multiply with 4, it is 2 power 2. It should be 2 power 30. I might have written there as 2 power 32, because of which I think I got this, right? So the actual total size is 2 power 20, which means p square should be greater than or equal to 2 power 30. Then p will be greater than or equal to 2 power 15, which means here it will be 32 KB. See, sometimes there will be some small calculation errors because when I'm doing these many questions, there is a chance that I might go wrong somewhere. So you please correct it, okay? And you please be conscious about what I'm solving. I might not be right always, but once you understand the procedure, you follow your own procedure and just check the answer. The answer which I do might not always be right, but the procedure that will be right. Okay, thank you.